So increasing function is a function such that if the value of x increases, the value of y also increases. Let's say, for example, a linear line which looks like something like this. The value of x increases and so does the value of y. And thus notice that the gradient is positive. Thus, whenever we have an increasing function, it means that the gradient is going to be positive. dy by dx is going to be positive. Now, and if we were told to find the range of values of x for which a function is increasing, we would determine the values of x by forming the equation as dy by dx is greater than 0. And solving this inequality will give us those range of values of x. So let's say, for example, we have just find the range of values of x for which this equation is an increasing function. So the first step is to find dy by dx. This is a quadratic, so the differential is 6x minus 12, which is a linear, and thus we will write this as greater than 0. Solving this would give us something like x is greater than 12 over 6 and x is greater than 2. This is the range of values of x for which dy by dx is greater than 0. This is the trick to solve such questions, and this is my answer. Although sometimes a question may require you to prove that a function is increasing and not just find the values of x. In such a case, the first step is always going to be completing the square and then proving that dy by dx is always going to be positive or greater than 0. For example, we have a trinomial here. Determine whether this equation is an increasing function. So the first step is to find dy by dx, which is in this case is something like 3x squared minus 6x plus 9, and we have to complete this to complete its square form. So we start off by taking 3 common and we're left with x squared minus 2x plus 3 inside. Now in order to complete the square, the first step should always be to isolate x squared rather, and we did that. Now we only have to deal with whatever is inside the bracket and complete the square for whatever is inside the bracket. Whenever completing the square, only deal with these two. So we have x square minus 2, a is x, and for this to be equals to minus 2x, we got to have a 1. Thus our b is 1. We need to make this equals to this. Then since b is a 1, so it's going to be 1 square minus 1 square. And we had a 3 here, and this 3 remains as it is. And this is the part we are going to deal with. Eventually, we'll turn out to have 3x, a is x minus 1 whole square, and this thing turns out to be a plus 6. And this turns out to be our answer. Now note, if I substitute x as minus infinity, it's gonna be positive because of the whole square here. And if I substitute as even if minus 1 is gonna turn out to be positive because of the whole square. Thus notice that whatever the value of x is, now notice that whatever the value of x is, dy by dx, that is the gradient, will always be positive owing to the square. You need to write this and you must write this in order to get full marks. Now moving on, what is a decreasing function? This is similar to increasing function where the concept is the name and the concept. So in case of a decreasing function, imagine a negative gradient and a linear line. So as the value of x increases, it causes the value of y to decrease, and thus the gradient is negative. If we are to find a range of values of x for which the function is decreasing, again we'll find dy by dx and form the inequality as this. So let's say we're given find a range of values of x for which the equation blah 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 is a decreasing function. First step is finding dy by dx. This dy by dx in this case is this is less than 0. A very important part. We are talking about decreasing function. Solving this would result in x is less than 4. So again, now sometimes the question may ask you to prove. Whenever you are asked to prove, first of all find dy by dx and then complete the square to prove that it is always negative or less than 0. So this is our equation in this case. So dy by dx is going to be minus 5 plus 6x minus 3x square. So is less than 0. We need to complete the square first, so I'll take minus 3 common, and I'll be left with x square. I'm working from right to left, minus 2x plus 5 over 3. I'll ignore this part for now, and then I'm going to complete the square. I'll do this thing with yellow. So x square is x, and I have minus 2. I know there's going to be a minus 2 because there's a minus here and not a plus 2, and is x, and I got what I needed, thus b is 1. So plus b square, and this is one part. So how about I enclose this in brackets here and convert this to square brackets here, and as a result of this one square introducing this, I'll have one square outside and this plus 5 over 3 as it is. Now simplifying this further will give me this part is going to be x minus 1 whole square plus 2 over 3. Once expanded, I'm going to have minus 3 x minus 1 whole square minus 2. Now notice that there is a minus 3 here outside the bracket. And if you test with a few values of x, substitute them, you notice that whatever the value of x is, the answer will always be negative. Thus, it is a decreasing function. And this was the whole concept of increasing and decreasing functions. You need to remember that in case of increasing functions, your dx is going to be positive and the value of x increases as the the value of y increases. But in the case of a decreasing function, you have a dx is going to be negative, the gradient is going to be negative. So as the value of x increases, it causes the value of y to decrease. And that was the whole concept, and using this concept, we're going to solve this.